All right. Geometry, lesson 64. We're going to talk about angles interior to circles. We've already talked about inscribed angles, haven't we? Inscribed angles. We know the inscribed angles are half their intercepted arc, right? Intercepted arcs are twice the inscribed angles, right? Here we're going to look at some other parts in these circles. We see the segment or arc is said to subtend. We're probably not too familiar with the phrase or the terminology of the word subtend. Okay? A segment or an arc is said to subtend an angle if the endpoints of the segments of or arc lie on the sides of the angle. So in this diagram, we see the angle EDF, which is this guy right here. Okay? Is subtended by arc EF. All right, so we have arc EF, and we have segment EF. So we have both a segment and an arc represented by the numbers, or by the letters EF. So we see that angle comes out and it's subtended, or it meets that arc and it meets that line segment. How are we with this so far? Does this make sense? Okay, kind of get the word subtend a little bit. Inscribed angles are one type of subtended angle. Another type of subtended angle is one formed by a tangent to the circle and a chord of the circle. So basically what we're going to see is this falls outside the circle. We get something like this. All right, so this is our theorem 64-1. I don't know. Let's see if we have... Yeah, AD, the question is, isn't that a tangent line? Yes, AD is a tangent line. And so what we're going to see is we're going to see the relationship between a chord that meets a tangent line. Okay? There's a really specific relationship, and it's not a hard relationship. It's not a complicated relationship. It's a lot like our inscribed angle to our intercepted arc. It's a very similar relationship. So it's 2 to 1. Okay, or 1/2. The measure of an angle formed by a tangent and a chord is equal to half the measure of the arc that subtends it. So it's a really complicated sentence, but basically we're saying that angle CDB. Okay, do we see that angle right there? All right, the measure of an angle formed by a tangent and a chord, that's what you're seeing, is equal to half the measure of the arc that subtends it. The arc that subtends this is this right here. Okay? So we're looking at the relationship between the blue angle and the red arc. Do we see that? All right, so what we're saying is that this blue, we'd say measure angle CBD is equal to 1/2 of arc BC. Okay, so just for instance, somebody give me a two-digit number. 20, is that what you said? All right, so let's say that we know that the measure of arc BC is 20 degrees. Okay, obviously it's more than that, but just for the sake of doing the math, what then would be the measure of angle CBD? 10 degrees. Okay? Does this make sense? It's not a complicated relationship. Okay? Now, the other thing I want you to see is that it's also true on the other side. Okay? We also have angle BC or CBA. So the measure of angle CBA is equal to 1/2 of major arc BEC. Okay, let's see. So let's say for a second that we have this information here. We knew that this was 20, therefore we knew this was 10, correct? You with me? Okay, so based upon this information here, what is the measure of angle CBA? CBA. It would have to be this side, because that's how the angle works. It would be 180 minus 10. Right, because they're forming a linear pair, correct? With the line ABD. Okay, so what's 180 minus 10? 170. So we're going to say that this is 170 degrees. Okay, so then what is the measure of angle BE, or sorry, the measure of arc BEC? What would I do at that 170? Multiply it by 2. What's 170 times 2? 340. Now, this is a complete circle, right? Which means it should total how many degrees? Does 340 plus 20 equal 360? Could I have said, if I know this is 20 and this is the major arc that corresponds to it, then I know that this is 340 because 360 minus 20 is 340? And then if I wanted to find CBA from that, could I have taken 340 and divided it by 2 and gotten 170? Yes. Do we understand how this works, or are we confused? Do I have everybody's attention? Okay. All right. And then we have theorem 64-2. The measure of an angle formed by two chords intersecting in a circle is equal to half the sum of the intersected arcs. Okay? So the measure of angle 1 is half the measure of arc AD plus the measure of arc BC. Okay? And the reason this works the way that it does is, let's say that I had this where this was directly in the middle, right? Perfectly in the middle. Where this point here is the center of the circle. I know it doesn't look like it, but that would make this angle right here a central angle, correct? All right? And a central angle is equal to what? The intercepted arc. So if I knew, say, that this was 40 degrees, what would I know about this angle right here? This would be 40 degrees, and vertical angles are congruent, so what would I know about this angle right here? 40 degrees, and then this would be 40 degrees, correct? Okay, but what they're showing me right here is, notice the angle 1, or this point right here, is this in the center? Is it in the center? No. So it's not a central angle, and it's not an inscribed angle. It's not on the edge or anything like that. So it's not 1/2 of its intercepted arc. So it is the average of the intercepted arcs, okay, going from here to here. It's the average of this and this. Because, and here's the reason that this has to be true, because these two angles have to be equal to each other because they're vertical, right? But it's very clear that BC is not equal to AD, is it? Right? Do we get that? So, I mean, probably X is not even a great, we'd say Y. So, X plus Y divided by 2 is going to give me angle 1. Does this make sense? It's an average. But students mess this up all the time, assuming that it's a central angle. It's not. They can't be. Okay? The same thing for 2. If I look at 2 here, right, its intercepted arc is here and here. So it's going to be AB plus DC divided by 2. Okay, whatever those numbers happen to be. All right, this is the end of the notes. Before we start answering questions, how well do we feel like we understand this on, like, let's say a scale of 1 to 10? Okay, somebody's at a 9, 7, 8, 7. What about 8, 7? Not at all. Okay, Jordan, how are you? At a 7. So we got several 7s and we got some not at alls. Okay, so I'm trying not to pick here, but if you don't get it at all, I'm probably going to focus on trying to get you there, okay? All right, so let's take a look through here, okay? Because if I got a whole bunch of people who get it, they get it. All right. So, all right, up here, let's look. If we're trying to solve for x, Maddie, we're going to use that last theorem that we looked at. Okay? So we've got this line right here and this line right here. We have this intercepted arc and this intercepted arc. So all we need to do, if you'll look at that theorem, was it 64-2? Okay? Is that we're going to take our intercepted arcs and we're going to find the average of them. How do we find an average? We take our two numbers and we divide by how many we have. We have two numbers. So we're going to take 58 plus 52 and divide it by 2. Can you go ahead and do that for me? $55, because we've got 110. 110 divided by 2 is 55 degrees. So x is 55 degrees. Okay? And so what I want you to see, hopefully you can see with this, is that with 52 here and 58 over here, I can tell that x is not a central angle, correct? Because what we would say is that if this was a central angle, we would look at this and say, well, this is 52 degrees, but this is 58 degrees. And what do we know about vertical angles? They have to be congruent, right? Would those two vertical angles be congruent? No. So that goes against our rules. So therefore, this is not a central angle. All right? All right, now we're going to take number 2, and we're going to go to that theorem 64-1. Okay? It says, what is measure angle WXY? So what's important when you see this WXY is for me, I want to highlight the exact angle that I'm looking for. Given that XY is tangent, notice that this intercepted arc is 216 degrees. So according to theorem 64-1, what do I want to do with that 216 in order to find this subtended angle? Were you going to say the same thing? All right, so can you tell me what 216 divided by 2 is? 108. Are we kind of coming up in our numbers a little bit in terms of how we feel about this? Okay? Okay? Because my goal is I want you as close to 100% on this, or a 10 out of 10 as we can get. All right? We want measure angle CAD. Maddie, what are you going to do with the 130? It's just like just the last one we did. Divide by 2. What's 130 divided by 2? 65. Okay? Again, not hard, just so long as we understand the relationship. Okay? Let's look at number 4. Okay? Jordan, what are you going to do to find BPD? BPD. Take half of what? Okay, the problem is that question number 4 is not the same rule as question number 3. Okay? These aren't things that look different, are not the same. Okay, so we're not taking 142 and divided by 2. Okay. Maddie, you got your hand raised. Perfect. 164 plus 142 divided by 2. Find the average. Is it 153 is what you got? Okay. And I'm gonna assume that you're right. One of the things that we should notice is that it's going to be less than 1 and greater than the other because it's an average. Okay, so it should be in between those two numbers. Okay, very good. How do you feel now, Maddie? What number would you say you're at between 1 and 10? I mean, we really only have 2 major things, and it sounds like you got both of them. Getting a little bit more confident? Okay. And a lot of these, you'll notice, just kind of repeat over and over again. Here, divide by 2. On number 5, 8, find the average. 6, find the average. 7, divide by 2, right? Do we see how it's either find the average or divide by 2, or maybe multiply by 2 and find the average, right? Not a whole lot of change in here. So let's take a look real quick at homework questions from lesson 64. See if there's anything in there that you feel like might give you some trouble. And it doesn't have to be a question from this lesson. If you see something that's been assigned that you've been struggling with, and you want some help with that before I cut you loose. What's that? Looking at the wrong lesson? Okay, lesson 64. This is why it's kind of handy to have a book. Kobe, anything in there that you can see? Jose? Nothing? Chandler, you see anything in there that you need? Number 3? 23. Number 23. Okay. Take a look at number 23. Number 23. Okay, it's giving you something looks a little bit like this. My picture's not probably super great. We got B, D, A, E, C, X, 17, 9, and Y. Okay? It says segment DE is a mid-segment. Okay, do we see DE as a mid-segment? Okay, what does that mean? DE is half of AC, yes. What do I know about point D? Point D, what do I know about that? If DE is a mid-segment, where is D on line BA? Good, all right, so it's got to be between or the midpoint. A mid-segment has endpoints that are midpoints of the sides that they are on, correct? That does mean that Y is 9, because I understand what a mid-segment does and how it's created, okay? And 17 is half of X. So what we could say is 17, let's see, 17 times 2 equals X, okay? You could. So, but basically we're going to see that X is what? $34. Was that harder than what we might have a tendency to make it? If I understand things about mid-segments, boy, that clears a whole lot of stuff up. We also know, not that we need it, but BE and EC are equal to each other because E has got to be the midpoint. No, the other side doesn't have to be equal. The right side doesn't have to be equal to the left side. But if I knew what BE was, then I would know what EC was. Or if I knew what BC was, right, I could just divide it by 2 and find out what the separate segments were. Okay, what did we say? This was number 23. Okay, anything else? Anything that you're looking at and saying, hey, I don't want to have to redo that question, and I know I'm going to struggle with it. 24. Find the magnitude of vector. Okay, so this was yesterday's lesson, right? Find the magnitude of vector. What is the vector? 1, -2. Okay, so basically all this means is that how far to the left or right am I going to go? 1 to the right, okay. And then what's the -2 telling me? Going down 2, Okay, right? So I'm going to go to here. What does the term magnitude mean? What's the asking? Distance. Yeah, not like distance, exactly distance. It wants to know the distance from here to here. Okay? So let's just do this real quick. What shape is that? What kind of triangle? A right triangle. Not a special right triangle because we don't know anything about its angles. Okay? Some of you are really quick to say it's a 45, 45, 90, or maybe it looks like a 30, 60, 90. We don't have enough information for that. Okay? But can I solve what part do I want to solve for to answer my question? The hypotenuse of a right triangle, correct? Okay? So we'll just go ahead and call this point C over here. Okay? What would I use if I'm looking for this? What is the length from A to C? 1. What is the length from C to B? Can length be negative? No. So 2. Even whenever I square it, it's still going to come out okay. So what I'm going to do is 1 squared plus 2 squared, or even negative 2 squared. But remember, distance isn't negative, equals C squared. Right? I got 1 plus 4 equals C squared. 5 equals C squared. Square root of 5. Okay. What are they looking for? They want the answer to the nearest tenth. So in my calculator, I'm going to type in square root of 5 and find out what that is as a decimal. It's a 1 decimal point. .23. So 2.2. And did they give me any kind of length? Nope. So 2.2 is my answer. So this is what I want you to understand. If they ever ask you for the magnitude of just a straight up vector like this, I can always just take the positive numbers that's given in that vector component form and plug them into the Pythagorean theorem and solve for C. Does that make sense? So hopefully that'll make solving for the magnitude of a vector a lot easier. Okay? Feel good about that?